Okay, I think we're going to go ahead and get started. Thanks for your patience. We always start about 15 or 20 minutes late here, so this is not unusual. First, I just want to thank everybody for coming. It looks like there's a great mix of people from downtown, from the kind of professional practice world, and a good group of students, so it's good to get those two groups together. The structure for the evening is going to be, we're going to give very brief presentations of three speakers. I'm going to give an overview of the book very quickly, just kind of going through some of the pages so you can get a sampling of what the book's like. And then we're going to have a Q&A, a kind of panel discussion, then Q&A, hopefully open it up to questions. I do want to start with a few thank yous. I mean, I don't do books very often. I usually do buildings, and books are very difficult to do. But it takes a lot of people, and Jason Roberts, who's here, was my assistant throughout this whole process and was fantastic. I couldn't have done it without him. Also, I want to thank Turner Construction, who sponsored the book and allowed the book to get bigger, more color, all those things that you want as an author but can never afford. And just thanks to the school for supporting me during this whole process. So I want to just talk a little bit about where the idea for this book really originated, and it goes pretty far back. I mean, and I would say it starts with the paperless studios that were taught at the school. I looked back, actually, it's in the fall of '94 when those first paperless studios were taught, and I taught one of the three studios. And, it kind of initiated a whole kind of discussion of digital technology and architecture. And that was pretty influential. About that same time, I was at a lecture downtown by Jim Glimpf, who was then at Gary Partners, and he presented a project, the Fish Pavilion in Barcelona. And he made a very kind of simple observation that really stuck in my head, which was that industry was changing rapidly, that there were numerous opportunities that were going to develop, and architects could either get on board or not. And if you didn't get on board, you were going to become more marginalized. If you did, there were enormous opportunities. And that has stuck with me for a long time. And then the third thing was kind of a funny story. In the late 90s, a lot of the people at the school that were interested in fabrication would often visit shops just to check out the equipment. And so I got wind of a place in New Jersey called eMachineShop.com online. And it looked like they had, the best tools out there. I was going to take my class out there. It was going to be a great field trip. And so I called them to set up the trip, and they said, they were kind of dumbfounded. They said, yeah, you can come, but I'm not sure what we're going to be able to show you. And so I was kind of curious about it. And after talking to them further, it became obvious that they had no machines. They were simply just a middleman. And what they did is took files online from people who wanted to fabricate stuff, send it around the world to large-scale industrial fabricators who would just fill in their kind of workflow gaps with these jobs. And at that point, it became clear to me that this is not just about fabrication. It really was about a kind of global network of communication, and that the potential in these technologies really revolved around that. So I'm going to go through samples of the book, and I'm not going to talk about every slide. I really just want to give you kind of samples of what the book is like, and I won't talk about every image. The book and the talks tonight are divided into three sections. Designing design is the first topic. And designing design, again, is something that I've been thinking about for a very long time and teach studios here about, is really just about the role that algorithms play in our design process. And the fact that they're becoming so prevalent that in some ways it's no longer an option to remain distant from that the design of a design system itself is becoming a problem for architects. That we can no longer just, allow software to kind of structure the context in which we design, but actually we have to get involved. Many of the authors talk about this. Some of the authors present case studies where they invent custom tools within their office to do task-specific jobs. And often it's about filling in a kind of gap that a standard software package can't do. In other words, it's about taking information from one software package and having it communicate with another. And in many cases, you'll see enormous opportunities open up. In this case, the diagram on the right is an interesting output from the computer model, which was, it was taking digital information from the model, coming out with analog instructions to send to a loom to weave this net. So in this case, the workflow was about stepping out of the digital into the analog. And that kind of play back and forth between digital, analog, digital, manual is something that I think is just starting to really be talked about, and something that I think is going to be very important, you know, as this technology develops. I mean, I think the first few years of this is really all about like just making it digital, just full-blown attempts to create kind of pure digital workflows in design and construction. And I think the reality that's starting to emerge is that it's simply not possible or even feasible. And so the question then becomes, you know, when do you step in and out of this process? And it's something which again, is more of a design problem than a technology problem. Some of the authors are skeptical. I mean, I purposely invited people to contribute that weren't just sort of gung-ho about the technology, but really were rather reflective about its potentials and its limitations. Neil Denari being one of them. I mean, he's associated with digital processes, but having built several projects now, I mean, he's begun to kind of reflect on how far the technology can go. And one of the more interesting discussions that I had was with Reiser Umemoto, who said right from the start, listen, you know, this is not our world, and we're very skeptical. And he used this interesting analogy to kind of describe that, which is, and this is just quoting, it is absolutely possible to derive mathematical formulas from a Mozart sonata, but debatable whether you could run the process in reverse and come out with a Mozart. So his point being that he was sort of questioning the capacity of digital tools to actually embrace and encompass the full range of sort of possibilities that lie outside of the digital. The next section is designing assembly. And this topic directly relates to digital fabrication, but I purposely sort of didn't use that term with the intent of trying to move beyond just this idea of file to fabrication and looking at the possibilities of architects starting to think about assembly processes through fabrication. So instead of just thinking about, you know, drawings that can be sent to CNC machines, it was really about understanding the broader implication of that and understanding how assembly logics could be embedded in design processes by taking that information and front-loading it in a design process. Several of the authors deal with this. Barco Liebinger has done some very interesting work where they literally look at the specific constraints of machines and then pull that into their design process to generate concepts. So designing assembly is, I would say, the kind of the sort of middle part of this process of design, assembly, and construction and industry. Now, many of the I wouldn't say many, a couple of the contributors fall into the category of consultants who, at this point in the development, play a critical role in kind of bridging design and construction. There, you know, firms like Design to Production here and Gary Technologies essentially play the role of taking design ambitions that architects come up with, linking it to processes of fabrication, and digitally making that connection. The partner from Design to Production told an interesting story when he was working on the project shown in the book, where he was hired by a contractor who had bought out the project and had no idea how to build it. And so what happened is that they essentially worked very carefully with a timber construction company, with the logistics on the site. They took all these kind of bits and pieces of information that would be important to understand to develop the workflow, and basically sort of encoded that in the process and developed a link, again, between the design drawings and the fabrication drawings. And Gary Technologies, is another firm that works very much in this vein, and is also, in fact, trying to kind of expand their services to deal with larger organizational issues around projects. It's also interesting in this drawing you see that sketches are still alive. Sketching in some ways is critical in kind of clarifying design intent in order to translate it into code. So a lot of people worry that the kind of direct hand-eye coordination connected to sketching is not part of this process, and in fact it very much is. And then the last part is designing industry. And this sort of section of the book looks at kind of larger organizational issues that are occurring in industry around integrated design and construction processes. It looks at the current status of developments around BIM, around IPD, but it also tries to go beyond that, and in some ways tries to take an opportunistic look at what is possible through these processes and not limit it to what is currently being kind of, let's say, deployed in industry. So in some ways it takes a position that BIM and IPD are addressing logistical issues having to do with these problems within design and construction, but it's not clear what impact it has on design yet. And that's something that I think as architects we have to be very careful of and just very aware of. Offices like Morphosis, who have always had a very intimate relationship with their fabricators long before digital processes, for them, these kind of processes have just been able to kind of take that interest and relationship to another level. And related to this idea of the role that architects can play in this, Tom Main, in one of the discussions we had in preparing the book, made the point that if architects don't continue to design challenging projects, even with an aggressive aesthetic agenda, that the tendency of this technology left to industry alone will tend to lead to very generic processes and very generic results. So he was taking a very adamant position that without design, without architects, the potential of all this technology runs the risk of just gravitating toward very generic results. And then finally within this category, Paolo Tombesi, who in some ways is kind of the outsider in this group, but takes a very different look at the topic. He really analyzes and sort of theorizes the construction industry in ways that is not very common, honestly, in the States. He's based in Australia and does very interesting work where he looks at the after effects of construction and does analyses of labor relationships, contractual relationships. He sort of understands what happens after the fact and then generating a database that potentially can become part of an information model. And this is an aspect of the industry side, I think, which is largely untapped, but has enormous potential. In other words, an information model is just that. It will take in whatever information someone finds useful. And the more we expand that, the more I think we begin to uncover new potentials. And the final contributor, John Nastasi, presents the work from the Product Architecture Lab at Stevens Institute, in some ways one of the pioneering schools around this topic. And they've been doing work probably for 10 years that a lot of people are just starting to see. And in some ways they're very much ahead of the game in trying to understand the relationship and the potentials between academia and industry. And I think it's something that a lot of schools are kind of touching on and struggling with right now, and including this one. So with that, literally with the whole book, hopefully showing just enough that you'll be interested to buy it afterwards. It's available back here in the back. So we'll go to the other three presentations and then have a brief discussion. So 3 speakers tonight, and I'm very excited about the 3 people that have decided or have agreed to do this, and that they come from very, very different perspectives on this topic. David Benjamin, who anybody who goes to school here knows very well, is the director of the firm The Living and director of the Living Architecture Lab here at Columbia. And he's also a professor here. What I find really interesting about David's work is that he sort of misuses optimization software. I mean, he takes software that's intended to be used for very, very specific processes and tasks and tries to open up the potential of that to a very, very wide design space. And it's something that I think is very unique and has, again, enormous interest and potential. Shane Berger is going to speak second. Shane is a kind of veteran around this topic. He was with Grimshaw Architects when the book was done. He since has moved to Woods Bagot and is the director of design technology there. And he's also the director of the Smart Geometry Group. And then finally, Phil Bernstein, who is vice president at Autodesk, teaches at Yale, and is probably one of the most prolific advocates for changes in technology and the impact that it has on industry. So it's great to have Phil here. Okay, with that, David.
Great, thanks, Scott. Here we go. Okay, so one of the things that was exciting to me about being part of this project and being part of this book, along with all of the other interesting people contributing and under Scott's great editorial direction, was that it allowed me to kind of reflect on and frame some of the research and thinking that I'd been doing about computation and workflows, including the stuff about optimization that you described. And so I want to kind of quickly go through a subset of the thinking and the arguments that I made in the contribution to the book. And it will touch on some of the current work that I've been doing along these lines. So the first thing I want to say, though, is that for me, kind of counterintuitively, a big part of the story of current digital workflows in architecture dates back to actually 1906, and this guy shown on the screen here, an Italian economist named Vilfredo Pareto. And in 1906, he published a thick book called Manual of Political Economy, and it was filled with these hand-drawn graphs and hundreds of equations, which basically are the algorithms of his era. And while the book was kind of underappreciated at the time, it has since become kind of the foundation for the study of modern microeconomics. But I also think that it's very relevant for architecture and the use of digital tools today. So one of the concepts that Pareto came up with in this book was called Pareto efficiency, and that's kind of shown by this graph here. And Pareto efficiency for Pareto referred to a society where nobody can be made better off without making somebody else worse off. A society in this state of equilibrium was said to be Pareto efficient or Pareto optimal, and a series of potential societies could be neatly graphed so that all of the Pareto efficient ones fell on a Pareto frontier, the series of best performing arrangements. So as an example, which is shown here in figure 5 in the book, Pareto imagined a society with a fixed amount of resources for producing bread and wine, shown on the X and Y axis here. And so for this simplified version of society, one option would be to make a large amount of bread and a small amount of wine. I guess that's over here. One option would be vice versa, shown up here. And for each option, if the production was efficient, then this version of society would become a point on this Pareto frontier, this curve right here. And since all of the points on this curve were mathematically equivalent, they're mathematically optimal, this frontier of points could be used to study trade-offs between different options for distributing resources. And for me, I've found that this Pareto frontier is actually embedded in a lot of the computational tools that I use, and the framework behind the development of this graph and this concept is very useful for some of the ways that I've been using computational tools. So basically this principle, the Pareto efficiency principle, can be used for the design of many problems, not only the design of a distribution of resources in a society. Engineers use it a lot, and they refer to this, this Pareto efficiency frontier. And in recent years, architects have used a similar framework with aspects of building design, such as the design of a structural frame with the objectives of least displacement under load and least amount of material required. With those two objectives, you would replace bread with one of them, wine with the other, and you would have a similar Pareto curve. So in this sense, the Pareto's book, The Manual of Political Economy, and the field of economics in general have in a way provided a foundation for the current interest in performance and optimization in architectural design. Architects today, like economists and engineers, are enchanted by efficient and optimal designs because they can be clearly identified. These kind of designs are so unambiguous that they seem inevitable, and they're so computationally pure that they seem desirable. But I would like to argue that, as Pareto noted a century ago, efficiency is very narrow. An efficient distribution of resources does not actually equal a good distribution of resources. An optimal design does not necessarily equal a good design. And along these lines, critics of performance-based approaches to architecture have argued that maybe good design cannot be reduced to mere numbers. It cannot be graphed like this. For them, judgment and intuition are crucial components of architectural design, with nuances that can't be quantified or graphed on the Pareto frontier like this, and these factors should not be ignored or diminished. In other words, to rely too heavily on performance and optimization as the drivers of design is to fall under a kind of dangerous myth, a myth of efficiency. But on the other hand, dismissing numbers and optimization, as Scott was getting at, may be equally one-sided, or at least may be unavoidable in today's context. And to rely exclusively on judgment and intuition to address complex architectural problems may be to fall under the spell of a different and maybe equally dangerous myth, a myth of creativity. So there's this myth of efficiency, but maybe there's also this myth of creativity. And I think for me, and probably for a lot of people writing in this book, the issue is not whether to choose one side or the other, to choose efficiency or creativity, but rather how to structure a relationship between the two and to balance their different strengths. And this is something that I think a lot of current workflows are working on. So one last idea that's been helpful for me before exploring a few examples is this spectrum, again, coming from kind of mathematics, but I think with useful applications to architecture, a spectrum between exploitation and exploration. So basically, algorithms can be used to exploit small differences and achieve a very efficient result, as shown on the left example there, optimizing the nose cone of a high-speed train. But the same algorithms can also be used to explore a wide design space and to try to derive novel results, to try to achieve some amount of performance, but also to uncover something that wouldn't have been uncovered before. And so if you kind of map the abstract design space of these two types of explorations, or two types of ways of solving problems, you might derive the conclusion that if you want to exploit small differences, then you want a fairly simple design space, as shown on the left. And if you want to explore design spaces, that's generally well suited to a very complex design space, as shown on the right, where these topological surfaces are an abstract representation of how complex the design space is. And so these are some of the kind of frameworks for me in thinking about workflows, digital workflows in architecture today. And I guess my own thinking for this essay was framed around the idea that, as architects struggle to balance the power of computation with the need to maintain some kind of control and creativity, as architects are trying to place themselves on the spectrum between exploitation and exploration in their use of design tools, then the workflow is kind of the site of design of where they kind of stake their claim, where they decide how to use these processes, where they decide how to move between qualitative and quantitative goals. And along those lines, my contribution to the book had me thinking about 5 specific ways that I think could be interesting and useful in navigating through this new territory. And I want to just describe 3 of them very briefly here. The first one is what I'm calling computing the social. And this is basically the idea that many aspects of design, which formerly were probably thought of as qualitative or almost by definition impossible to quantify, are now being encroached upon by quantitative tools. So this is a company called Anybody Technology. They model things like this. But basically they're modeling ergonomic comfort. So comfort, typically a thing that we would think is qualitative, it's hard to describe in numbers, but it turns out, as in many aspects of our society beyond architecture, there are people who are developing more and more powerful computational tools with more and more data to feed into them, and they're able to start simulating things like this. This is related, so this is still the same topic, to tools that are doing things like modeling crowd behavior. And this tool called SmartMove by Bureau Happold is actually like several other tools that exist in the industry. In this case, modeling the flow of people around a stadium, obviously. This is one of their demos of the ability of this tool to be to show visualizations in real time, to be manipulated in real time, to identify things like bottlenecks, but also the paths, most likely paths that people would take. They show kind of heat maps of where congestion is or where problems are. And it's the start of modeling these things that seem certainly possible, but also a kind of new frontier, and maybe even in some cases make us a little uneasy. The idea of modeling movement of people, comfort of people, behavior of people, something that seems beyond computation in a certain sense. This tool, very similar, used for simulating things inside airports, and it includes the study of timed events, like when certain flights arrive and where people would go to pick up their luggage. This is now being combined in a very interesting way, which I won't go into now, but I learned a lot about by talking to the people at SOM who design airports, including Derek Moore, who was a great advisor to me on this piece. And he basically let me know that although in the design of all the airports that SOM does, they use these intense computational tools and these simulations of people like I just showed, they also still, to this day, do a lot of surveys and field observation and ask people when they're showing up at the airport, what flight are you arriving for? How early do you get to the flight? How many bags are you carrying? Did you arrive by public transportation or by a car, etc.? And it turns out that these things, for the moment, are beyond the ability for SOM to integrate into a computational tool, but still very important to the process, and also still very quantitative, but not yet modeled. And it turns out the behavior of people is very different in different cities, which makes sense. And of course, this is related to William White's studies, which probably everyone knows a great deal about. The last example along these lines, which I think is potentially the most interesting, is a series of tools, including this one called Vacate by a lab at the University of Buffalo, which is trying to model psychological behaviors. So they're modeling crowd flow through architecture, like the previous model by Bureau Happold, but they're really trying to study things like the effects of a group sticking together, shown by these dots here, in evacuating an airplane. So how do people behave, not just when they have a single uniform rule between all people, but when they have different needs based on their profiles. This is modeling the behavior and evacuation of someone who's disabled and how that would work. There's also the modeling of panic, which was shown earlier in the example with the smoke alarms. And this interesting comparison shows how evacuation would work when comparing competitive behavior versus cooperative behavior in general, the kind of psychological vibe of the plane when the evacuation is happening. So I think this is the tip of the iceberg for a series of tools which will be coming and which are already here, which will model these things that we used to think of as impossible to model, but now might be possible. The second example that I want to describe briefly is the idea of using optimization creatively, and that's what Scott introduced already. This is a project that my firm, The Living, worked on in collaboration with Bureau Happold, or they were the engineering consultants, and we were basically trying to design a fixed canopy shown by this gray frame and try to determine what would be the best structure to support the canopy. So if you consider all of these dashed red lines to be either to exist or not to exist, then the idea was let's explore which configuration would be best, and there are literally billions and billions of possible configurations, so we used computational tools to help us explore that design space. To make a long story short, we basically set up a system where an algorithm would turn on or off different sets of branches. Then we would analyze each model in this structural software, Autodesk Robot, get a structural score, and then we basically were trying to optimize for two things: best structural performance, but also least amount of total red material. So it's a fairly straightforward problem, an optimization problem that's often used by engineers and architects. So it's not unusual in a setup of a set of goals to have best structural performance and least amount of material. Like many uses of optimization software, we generated thousands upon thousands of designs. These are 25,000 different designs. The blue points are actually our Pareto frontier, looping back to that original diagram from 1906. And this is a feature of the software that's built in, so Pareto's affected this software for optimization. We honed in on this design here in the red circle, partly because of our design choice. But here's the most interesting moment in this context is, I hope you can see the red lines, because they show that if you look on the right, you see what was the predicted design by the human engineer, the great engineer that we worked with at Bureau Happold. They said, to solve this problem, what would be the most efficient way to put structure, to make a structure for this canopy, given the setup of our branching columns? You would probably want to place a column around every other cell in the perimeter, and each of those columns would have only 2 branches. And we were able to measure the performance of that design, and we thought that was probably going to be hard to beat because it seemed like a good solution to the problem. It turned out through the design software, we uncovered a possibility that wouldn't have occurred to us if we only had a few tries to design, and it was beyond our rule of thumb in designing structures. And it was basically to make 2 clusters of columns, one at the lowest point and one at the highest point. This was one of the design that we selected, but a series of designs had this general trend, and we were able, in retrospect, to understand why that might have been the case, which I won't go into detail here, but it was basically, we thought, because while this structure looked like it might be a dome, and so a good way to support a dome would be around the perimeter, it turned out it was probably behaving more like an arch. And for an arch, picking up the structure at these 2 points, especially since it was not symmetrical, since it didn't go as low on the left side as the right side, picking up the structure in those two places and basically a line of structure in those two places was probably a good solution, and it turned out to be the one that we constructed. And so the third and last approach that I want to describe is potentially the most radical and also still the most underdeveloped, but it's the idea that these tools, while we might think of them as being reducing some of the complexity of design to pure numbers, and they certainly do that in some cases, these same tools might be able to be turned on their head slightly in order to engage more judgment and more human input into the process than was previously possible. So I call this democratizing design, and here's a quick but very rough example. This is an exploration of a tower design where you have a mixed-use tower, hotel on top, office and retail, a series of inputs and goals. I won't go into the process of how this workflow works, but you see that there's a variety of different design permutations possible, different ways to graph the designs according to multiple objectives, some having to do with things like landmark view, some having to do with percent in leasing depth, so kind of financial returns, some having to do with public space, and some having to do with things like radiation, so environmental metrics. All of these tools all of these visualizations are part of the normal set of design tools used in this multi-objective optimization. But what's most interesting to me is that potentially these same design tools, which again could seem like they would produce a design that's inevitable, that's just efficient, that's reducing our creativity to cold-blooded efficiency, they may actually be able to be used, if there's the motive there and the will there, to debate values, to discuss what is most important. And the reason that that is so clear to me is because as soon as you have a score for public space, a score for environmental performance, and a score for financial return, then you can start pushing and pulling the filters, the levers, deciding which one should have more priority in your design, and basically debating what is important about design in a way that I would argue is sometimes difficult when the design is more intuitive and the design process is more opaque. So this is an example, again, of just tools built into the design interface where you can start to filter out designs by pulling these green levers. If each one of these bars is one of the objectives and how your design scores on those objectives, then you can start filtering out designs, and it can be very clear to all of the stakeholders which ones you might want to filter out. So you might want to filter some out that rotate more or less based on an aesthetic concern. And maybe all of the players in the design process would have to agree on that, from client to engineer to architect to contractor. You could push and pull other different levers, and you basically hone into different types of designs depending on which levers or filters you're pulling. And a final way that's offered by this tool is to basically, after you've generated thousands and thousands of designs through the automated process, the process that's so-called optimizing, not only do you not achieve a single best design, as Pareto observed, he said you have this set of designs, so it requires a choice, a trade-off to decide which design you will choose. But also, after the fact, it's mathematically very, very easy to refilter the designs based on reweighting the objectives. So here's a baseline scenario. You probably can't read this text, but each one of these corresponds to a different objective. Remember the ones of environmental performance, financial performance, public space performance. You're getting different scores for each of those, but you could decide that maybe public space performance should be twice as important as financial return, or vice versa, or environmental performance trumps all and should be 3 times as important. And once you reweight those, then you get a series of different top designs that have different forms, and then basically this tool becomes the focus or the enabler of a debate about design that could extend not only to the typical stakeholders like designers and engineers and client and contractor, but it could also extend to the public. And so finally, to kind of complete the circle for me, just a very brief observation that Pareto himself, Vilfredo Pareto, who was important for me in framing this context of the use of computational tools, in a story that's actually interesting and fitting to me. In 1916, which was 10 years after his first book, he started to distance himself from that book, and he published a completely different book, but equally large and full of his treatises. And this was called The Mind and Society, a treatise on general sociology. So by that point, he had resigned from the chair of political economy at the University of Lausanne. He had tired of the oversimplification involved in economic theory. He'd become disillusioned with the terrible track record of economic predictions. He'd abandoned the fundamental economic tenet that people act logically. Instead, he said that people are non-logical, but they believe they are logical. And he now believed that the earlier charts and his Pareto frontier needed to be reevaluated, or in other words, updated. There needed to be more. Pareto's simple mathematical models were no longer sufficient to bear the weight of this multidimensional world. And it was clear that the models would have to change. And I guess what I am arguing here is that perhaps the same is true for our early versions of digital processes in architecture. Perhaps they need to be reevaluated and transformed. Perhaps there needs to be more. And the real question is how much of the original model will remain, and whether the new framework will look anything like the one which has been so influential and has taken us so far. Thanks.
All right, this will take me just a second. All right. So what I thought I'd do is actually give you all a quick little framework of where I come from in terms of computational design. It's something that I've been involved in back to about 2003, 2004. From the very first time I saw Robert H. present some work from Waterloo Station by Grimshaw done in a very, very early version of generative components at that time. And I think where I come from with all this is very much grounded in materiality, very much grounded in how you make things, how you make design forms become real within the built environment. I don't know exactly the full makeup of the people in the room, but I'm assuming actually quite a few of you, if you're from Columbia, are aware that the origins of computer programming come from the world of making, specifically the Jacquard loom. This is just one of the examples of one of the punch cards up here. The punch cards for the Jacquard loom enabled replication in art, a sort of abstraction of what was in the physical world into something that could be made into a copy after a copy after a copy. And the moment you start to disconnect this way of making from the actual object itself, it allows certain levels of abstraction. And this, of course, then led to the earliest work in computer programming languages. There's a book by a gentleman by the name of Nelson Goodman called Languages of Art, which talks about two specific kinds of art. The first one's referred to as autographic, which is where the object itself is the art is the artifact itself. So if I'm making something with my hands, I'm carving something, I'm painting something, I'm drawing something. That is referred to as an autographic type of art. Allographic, however, of course, with the word allo at the very beginning of it, the artifact itself is symbolic notation. So examples of music, architecture, a number of different types of art, and it's a set of instructions. Of course, it enables abstractions, it enables translation, modification, and interpretation. It also allows you to have a malleable set of inputs and contexts, and the context part is quite key here, and I'll get to that in just a bit. There are many stories of the ways at which we kind of move from tight to loose set of symbolic notations. You've obviously got the punch cards of the Jacquard loom all the way down to Yoko Ono's work in art with writing instructions on index cards. And then in music world, you've got everything from Bach to Monk. Music is one that I come back to on a fairly frequent basis. It's kind of my frame of reference for how I think about architecture, how I approach computational design. There's a mention in Malcolm McCullough's book, Abstracting Craft. It talks about the move from entity to type. Again, a level of abstraction that you get from the specific to a description of that element itself. On the left side, we see the what's referred to as the head and the main chord changes for the piece In Walked Bud by Thelonious Monk. On the right side, you have Xenakis' Metastasis, which was the piece that was performed in the Phillips Pavilion that he worked on with Le Corbusier. Now, in these cases, the melodies is given in some capacity, but there's always room for interpretation. And the performance then becomes a live interpretation of this symbolic notation, infused with some sense of history, of emotion, and reflective, again, of that immediate context. For me, design and making is about communication. It's about how people speak with each other. It's about information flow, everything from formal side or semi-informal to social. It's about creating a design space in which we work, where you can embed your aesthetic approach, your design intent into any form of geometric controls. David shows examples of this. There's a lot of examples of this in the book as well. And it's also about inclusion of predictive analysis and feedback loops for direct control. It's multidisciplinary and agile. Now, there's three different kind of threads or workflows that I'll talk about here in discussing design for assembly. The first one I'm just referring to as automation of the analog. The second one I would refer to as just general augmentation. And the third one is craft, the integration of craft in the process. And I'm going to show this in a couple different examples. Some of my work I'll show is from Grimshaw, which I started at in 2003 and finished up in, I guess it was 2012 now I think about it. No, 2011. Sorry, I'm not remembering correctly. I'll also show some work in my current firm at Woods Bagot, and then a little sprinkling of some smart geometry in there. And then lastly, some examples of work that I've seen in people whose work I admire from around the world. So the first one I'm going to talk about here is specifically the automation of the analog. It's talking about communication downstream, communication where you have something you've designed and you want to communicate this to a certain fabrication process. This is design as manifested through digital processes directly. Now, big question that comes up, what is it that you need to communicate? What do you need to hand over the contractor, hand over to the fabricator for information? We're kind of blessed with this idea when we're in university. We get very used to the concept of handing over information to fabricators directly. We're going to make things directly with machines all the time. It doesn't happen all the time. This specifically is an example of work. This is the Fulton Street Transit Center, which is in Lower Manhattan, a perfect example of working for a government institution where there was a very strong line between our design intent and the means and methods at which it was going to be built. So in this case, we knew that we couldn't count on a particular fabrication method, but we had to communicate our intent. We had to communicate the idea of how this thing could be rebuilt in a variety of different means. Now, we did meet with Permis de Lisa. We met with a bunch of different fabricators who gave us some sense of where we could go with this. And we ended up with what is effectively a geometric method statement. Fairly common in architecture, any sort of complex geometries. You'll try to find a way to describe that geometry such that anyone can open it up in any software platform, any type of fabrication method, and rebuild it using the techniques that they want to. The second method here that I'm going to talk about is other methods of communicating besides geometric method statements. This is specifically a project called the Museo de Acero, which is in Monterrey, Mexico. And the part that I'm going to talk about here is the cast hall, which is the outside of those louvers that you see. It's kind of glowing a little bit from the inside. Trust me, it's not on fire, but it's supposed to feel like that. The idea with this one, this is all about geometric control systems, and geometric control systems that give you a very simple, clean output that was necessary for the for the assembly on site. So on the left side, you see the overall design intent, which is a nice, smooth opening of the louvers on each facade. Next piece in, you see the control system, which is very much kind of like a sheet of paper. So if you want to bend something up, it rotates the louvers correspondingly. Fairly simple system, but we want it to be as playful and active as possible for us to be able to do a lot of push and pull in this. And as we move further down the line, you see it just real simple, goes out to a schedule, goes out to an Excel spreadsheet. Now, this specific case here, what was interesting was that we received the request for the final design on a Friday, It was already built into a parametric system for manipulation. So on Saturday and Sunday, I sat down with the project architect. We did a lot of push and pull. We had one screen up. I had two screens, two nice large screens actually. One which was the graphic representation of what we were getting as well as the push and pull. And on the right side was the data that was being output. And this is in about, I think, 2006, 2007 is when we were doing this work. The benefit was we were to, in a live way, be able to work everything from the original design concept all the way down to the information that had to be handed over to the assembly, the people that were doing assembly on site. The schedule was given to the contractor on Sunday night, and louvers started rotating on Monday morning. Another example of this workflow is symbolic of this concept of designer as tool builder, and this is something that comes up a lot within kind of parametric and computational circles. This is another portion of the same project. This is the steel gallery roof. So on the left side, you see the design concept, kind of a folded metal plate structure. The intent was to use the structural properties of folded metal plate in order to carry the load, to carry the distances that we wanted to have. We want to be able to manipulate the inputs and the outputs and to have an iterative feedback loop. So what you see here is basically a representation of physical prototyping, of structural finite element analysis, and artificial illumination and acoustic simulation, which then gets handed over to a different type of fabrication method, working with a different subcontractor down in Mexico. In this one's case, though, what we have to understand is that the drawings and assembly sequence needs to be reflective of the local trades. Again, we can't just hand anybody the same set of drawings. We're not handing them a 3D model. They're going to build it the way that they're used to, so you have to speak their language. You build in that ability to speak that language of the local trade so that they can build exactly as you had originally designed. Another aspect of this process, the kind of automation aspect of it, there's a good example. This is in the translation of design into G code. Now you see, if you read the piece by Fabian Schur from Design to Production, he talks quite a bit about the use of G code, and there's a couple of other pieces in there as well about this. This is specifically an example from the Smart Geometry workshop in Barcelona in 2010. We got to take over an old toilet factory. No toilets left over, but it was a nice big open and loud space, and got to play around with KUKA robots, with automated fabric cutters, industrial laser cutters, a whole series of different machines. This specific team developed a conceptual form and then automated the cutting process using this KUKA robot. So there's an automatic script translation down the line. So they knew what their fabrication method was going to be, and were able to automatically generate that code without having to go through anybody else. The same group actually did some work a few years later, so you may have seen the quadricopters flying in these same sort of foam bricks as well. I don't know if we're quite ready to use quadricopters to build skyscrapers, but it does give you a sense of where these things could be going. Again, you're thinking about the downstream process at which you're going to fabricate with, and you're building in a system that will automate that through. This is actually a nice animation. There's a certain amount of lust that certain people get about watching robots make things, and I'm one of those people, so I enjoy this type of stuff. Yeah, it's quite nice. This specifically is from Bemo, who does a automated standing seam metal roof. The whole piece of equipment itself is actually inside of a shipping container, so it can be brought directly to site. Now, there are many instances at which digital fabrication have enabled us to do things that were not economically feasible before. This has had, though, I would argue, a limited effect upon our ability to really push the design process in consideration of digital fabrication and craftsmanship. It simply enables us to have a faster result at lower costs, and not always provides us with new methods of craft that will actually transcend this technology. The question I always ask is, now that you have access to this type of technology, what are you actually going to do with it? Hopefully it's something more interesting than just purely automated repetitive tasks. There are opportunities here. There's a recent article that was published, and I'm not recalling the magazine last week, was quoted as saying software is eating manufacturing. It talks very much about this new working class in the United States where it's less about labor and more about coding. There's opportunities that we could have as the United States starts to transition over to modern fabrication methods, more use of digital fabrication, which can provide us with an opportunity to re-engage craftsmanship. In terms of augmentation, how you further augment the design process, how you bring in material information, how you bring things forward, talking much more about communications in both directions. Communications both upstream and downstream, and it's designed for both material and machine. Upstream, it provides us with the physical constraints, and it brings forward the process of making to inform concept design. Now, in Scott's book, he makes a comment about detail as being an accumulation of various materials and trade construction tolerances. This is considering all aspects of that and building it into a parametric system. We have an opportunity as designers to start building in material and construction restraints and to greatly benefit the downstream manifestation of design. By taking on different types of parametric tools that were originally created for the industrial and product design industry, it allows us to jump into things like solid parametric models, which enable us an active dialogue with the physical when we get all the way down into detailed design. Prototyping becomes really important, and this is a above photograph from one of the smart geometry workshops in Copenhagen in 2011. Now, it's not just about digital prototyping, just pure simulation within the computer, but it's about building the physical prototype. It's about having a feedback loop in that process of making, digitally simulating, fabricating, making as a constant back and forth loop. It's a simulation, also offers an opportunity to simulate fabrication and assembly processes and embed material efficiency. Now, this process can be engaged very early in the design process. This is a project that I had a chance to work on with a couple of people in both of our New York and Sydney offices to connect in with. And one of our guys, I don't think he's actually here, has been leading the process on this. This is a project called Win Your Walk in Sydney, Australia, which starts to take into account material, fabrication, cost constraints, and assembly very early on in the concept design process. So even in schematic design, you have the opportunity to work with potential fabricators and to think about new opportunities in digital fabrication and assembly techniques. This sort of method actually enables you to work at multiple scales and multiple levels of abstraction, from concept through to construction. It also allows you to start consider simulation of assembly. That's something continually talked about. One of the things that contractors get the benefit of through entire BIM processes is the simulation of construction sequences. And through the engagement of the simulation of those construction sequences, we can create much more efficient building processes. So I'm going to skip forward just a bit here in the interest of time. So, as design and construction starts to move towards processes inherent in product design and manufacturing, material and fabrication processes through simulation, all these things become an opportunity for creative use in the design process rather than a late in the game constraint. We're able to actively engage fabrication techniques and material constraints. This is some images here, or very slow animations, I should say. I won't speak slower, by Gregory Epps from RoboFold, who does a lot of work with curved folding structures out of sheet metal. So by understanding the opportunities that you have in working with the material, considering those constraints, and then actually exploiting those opportunities in digital fabrication and in material, instead of designing to the machine, you're actually designing with the machine during the entire process. This is some examples of work by Philippe Bloch, who's been doing some exploration of Gustavino vault techniques for thin shell masonry structures. I find this one particularly fascinating because he's considering both the structural capacities of these thin shell vaults, the material constraints, as well as the fabrication order. By calculating the forces, he can actually better design the patterning of that material interactively. So you see basically the tiling of these pieces are actually reflective of the forces that are inside. And actually the instructions for fabrication are very important. This is all fabricated by hand, one by one, but the order at which these tiles are actually assembled is key to their structural capacity. This is further extended in his work when he started to look at the kind of historical Gothic church designs and specifically non-reinforced masonry vaults. And it represented for him a desire to discover how these vaults operate structurally through material and form and embed that in a new design space for creative exploration on his own. See if this animation works. That seems to be okay. So you see a perfect example of this where he's actually able to work collaboratively with a stone cutting company in Texas, and this is on the design of a pavilion in Texas. So he's able to consider design, fabrication, and assembly as an interactive process of the design. Each block is shaped by its location and the structural forces that actually pass through it. You can see the forces on the right side. This allows you a live regeneration of the block patterning during form exploration and an embedded material and structural logic. The logic of fabrication also serves another constraint for Philippe to ensure that this entire system is actually possible on the equipment that's been given to him. It allows him a simultaneous connection between form, structure, material, fabrication, and even assembly. Now, not all of us get to work with a saw like this on the right side. It's much larger than I think I've ever seen. I think it'd be a little frightening if anywhere was near it, but it presents him with a tremendous opportunity to realize very large-scale forms and design everything from the original concept down to its fabrication and assembly on site. Now, exemplary use of material and fabrication in the pursuit of craft you can see in the work of Gaudí, and especially the modern work that's happening in Sagrada Familia by Mark Berry and his team at RMIT. Through a consideration of the geometric aesthetic as defined by Gaudí, and in an integration of classical and modern fabrication techniques, it allows us a new kind of modern digital craft as manifested in the physical world. It's through this integration of the digital and the physical that we can transcend the limitations of either. Now, for me, what I start to notice out there, when we look at the next generation of designers, which some people call the millennials, which I'm sure actually maybe about a third of you in the room are in that group, there's a much stronger interest in making things. It's about a desire to make the virtual manifest in the real world. And everybody in that sort of group, and even in the generations that surround these groups, are taking their cues from the mixture of the physical and the digital world, and are interested in working a collective of voices, not a single voice. Our goal should actually be to enable a continuous design to production and workflow, to design the environment in which we explore form and performance, to design the environment in which we realize form and space through materials and assemblies, and design the conditions within the industry where we can develop the next built environment. It's all about communication. How do we convey design intent? How do we listen and integrate the input of others? And what can be automated and put into a rig to enable creative freedom in this sort of workflow? Computational models have a life from concept down to construction. It's about managing information flow. What is the role of the designer in this new environment? Do we start to move design services out of silos without a defined time frame and start to bring fabrication and construction forward and push design downstream, enabling physical and digital prototypes, center design and production around a collection of overlapping processes, and enable parallel processes through integrated models? Our models will have a life beyond us. This is something that I don't think a lot of people quite realize. We're in this process right now where there's so many contractual blocks between, or what we feel we should have when we hand over our models downstream. We want to protect our intellectual property. We want to protect everything that we've created. That's not where things are going on in the future. We need to redefine our relationship with what intellectual property is and start to hand these things further downstream, as well as bring those items downstream earlier on in the design process. A couple weeks ago, I was listening actually to a live bootleg recording concert of Miles Davis' Second Quintet. This is actually not them, but maybe some of you might recognize who people are up there. Personally, I've always felt that Miles Davis' Second Quintet is the best of each of the ones that he tended to work with. And for me, it's a perfect synergy of framework and freedom, order and fluidity. It's an example of a live art performance that's reflective of material, context, and intentionality. And about midway through my personal short-lived career as a musician, by the way, short-lived, I mean high school, about it, I developed a fascination with how live art can actually spring from communication between individual parties, and with the relationship between symbolic notation and the realization in its auditory, visual, and physical form. I do hope someday that we can achieve that level of creativity and intensity in designing for the built environment. Thank you.
Let's see, do I allow this? Well, I'm a great admirer of Scott and Scott's ability to create a context in which people with seemingly completely different interests somehow align their explorations. And so even though we didn't plan at all this discussion tonight, Scott somehow has skillfully chosen three of us from the book who are exploring a series of pretty adjacent ideas. In the instructions I got from Scott were kind of twofold for this talk. One was, don't talk about technology. I said, I'm a vendor. How am I not supposed to talk about technology? But I'm not. I won't talk about technology. And the other was, don't repeat the stuff that you wrote in the book. Try to extend it. And so in my chapter in the book, I talked about this question of the relationship of the position of architects in the industrial production of buildings and what the act of design meant in terms of creating intentions for outcomes and final artifacts. And I asserted this idea that architects are beginning to have some of the obligations that were, I think, really spectacularly talked about by both David and Shane to design processes as well as artifacts. And since we finished the work on the book, I've gotten really interested in this question of value propositions and how, if you're going to really interpret the question of what this issue of design and meta design is, the process that you use to actually make the thing and the process that you use to design the way you make the thing, where is it that architects deliver value in that sequence? And in a way, this is something I've been thinking about since I started teaching professional practice at Yale. It feels like a really long time ago. And so this semester, I decided that I was going to try to explore the problem in a different way. And so what I'm going to do just very quickly is take you through an argument that suggests that some of the themes that David and Shane have talked about, which is the mythology of design intent, the question of the relationship between the creation of that intent and how it's executed, has to be positioned not only through tools, not only through procedures, but in the business context in which all this stuff is going to happen. And I'm just now starting to work on this problem. So this question of the value proposition, in other words, what is it exactly that delivers value to the exercise of the making of a building, I think is a kind of secret sauce or a catalyst that'll let us kind of think through this problem. So I'm teaching this course this semester with Brian Kennan, who's my counterpart, he's my professional practice counterpart up at Harvard, called Exploring New Value in Design, New Value Propositions in Design. And what we're doing during the course of the semester is looking at different kinds of business models, the nature of the supply chain, what other kinds of designers and artists do, and how their activities are translated into value, because that value, at least as it's interpreted in the business context, is the way different players get positioned in the process. And so my students have been going through this exercise where we're doing kind of basic concept building, and so one of my first teams tried to explain to my other seminar students what a value proposition is. What is it? And the first sentence here from Wikipedia, that a value proposition is a promise of value of something to be delivered and a belief from the customer that value will be experienced. So there's this kind of idea that a proposition is going to do something in the process and that proposition is going to receive something. And interestingly, that led immediately to the existential question that we've been talking about tonight, the question of the mythology of art versus what Scott was calling in the book procedural efficiency, or the mythology of insight. Can architects somehow synthesize things and see things in a way that's different versus optimization of process? And so two of my students, Yasmin and Tegan, created this thing called the Yaz-Teg architectural hierarchy of needs, which they derived from Maslow, where they said, well, at the bottom are boring things like cost and schedule. Then on top of that is being efficient. Then you get to the fun part, design. And on top of design is your essential value proposition as a practice, which is your brand, the thing that you do that's different than everybody else. And what they proceeded to assert immediately in week one of the seminar is efficiency and cost and schedule are things for contractors, and architects should only be focused on design and brand. And this gave us some really interesting food for thought. Now, if you're going to explore this question of the meaning of the mythology of insight, which is the question of the deliverable, of the ineffable, versus the procedural efficiency question, you have to interpret that in the context of the larger economic forces that are driving the industry. And I've gotten to spend a lot of time thinking about this over the last couple of years. And the basic value problem was articulated by Paul Morrell, who's the chief construction advisor, who's been driving the BIM agenda in the UK. And he said, the construction industry's business models are fundamentally broken. Everyone is looking for how quickly they can break the bargain on a project. So when Shane talks about the distinction in a public project between intent and execution, he's talking about the client attempting to control the breaking of the bargain. We must change our business drivers and our business processes. And so the overlay to the things that you've heard in the previous two talks, at least in my view, is this question of what is the value relationship between the desires of the three players in the process. In other words, this is Pareto in the second part of his career, I guess, David, right? Which is the client who wants this thing called a building but doesn't really understand how to get it. A designer who's going to create this very abstract notion called intention, which is, when it's done, I think I'd like it to do these things, and the builder who's going to actually execute it. Yet we use these weird artifacts called services contracts on the left and construction contracts on the right. Services contracts are about thinking about stuff, and construction contracts are about making stuff, and there's no integrative association between those two things. So not only is the value proposition broken and from the outset, the sociological structures of the industry are broken also, and they have to be in a way kind of attacked. And even the characteristics of how things flow through that structure are incompatible. I assume that students in the room are familiar with the concept of what's called the standard of care, which is the measurement of competency that architects deliver their services to clients. And it's a very, very sophisticated concept, which basically says, the job that you do better be as good as somebody who knew what they were doing. That's the measure of the standard of care. A competent person doing the same thing would have done this. And as I like to tell my students, if it doesn't work out, 12 people who could not get out of jury duty will decide whether or not you were competent. And that doesn't, it's kind of a broken construct. On the other side is this idea of the contractor delivering this thing called a product. But the governing legal doctrine in the United States for that is something called the Spearin Doctrine. And the Spearin Doctrine says the information provided by the client to the contractor for the making of the thing will be sufficient and complete for its making. So there's this kind of judgment thing going on the right, and a product question going on the left. And the structures themselves are kind of incompatible. So in that context, we have to start looking at this question of the mythology of the insight of design, or the idea of intentionality, versus the execution of a project and the procedural aspects of what the attempts to reach process efficiency are going to mean for how architects actually do their work. So, David did a much better job of explaining this than I did, but in this day and age, there's a huge amount of analytical information which is available to a designer. The design process itself is beginning to shift from experience and judgment to knowledge and measurement and data. And David does a much better job of explaining that than I do. And I have much less sophisticated videos than Shane. But this kind of information about the behavior of a thing as you're designing it is immediately available to the designer during the act of design, which eliminates or demythologizes or democratizes the idea of the design process and makes results very, very explicit. So suddenly things are incredibly measurable to quite extraordinary levels of detail, to the performance characteristics of subcomponents as the building is really beginning to be put together. And not all of these things are about the architectonics of the building. This is some work that we're doing with some researchers about using building information modeling and computational fluid dynamics to do infection control in operating rooms. If you can understand how air flows in an operating room, you can actually control the degree of infection in that room. And these are the kinds of things that computers are really, really good at. They allow these kinds of analyses to be directly delivered to a designer as that designer is doing their work. But most of our current fascination, at least up to maybe 3 years ago, has been with using these strategies for the making of form. This is an image from my chapter of the book that Zaha Hadid's office provided me. And it was really about parameters and scripting and the digital making of shapes, where the value proposition is actually about a whole different set of ideas. It's about measuring outcomes and being able to make commitments about how things are actually going to perform. if that's really true, we get into a completely different set of questions about what Shane was describing as the communication phenomenon, or the design of the process, and who takes responsibility for the design of the process when it's oriented much less around judgment and this concept of the standard of care, and much more about outcomes and how things are actually going to work. And we introduced this concept to our students at Yale in their second semester when they do the building project, where I put this mathematical model of this house that we're building up that shows them the relationship between time and money, or why we're going to use a huge amount of free labor to spend $100,000 and build a house that's worth $500,000 in a low-income neighborhood in New Haven. That has a whole different sort of Pareto-esque set of issues that we'll get into later. But what we're trying to introduce to them is that there are parametric considerations, even in the beginning of a house design process, that they have to think about, and that the definition of meta design in this construct of the obligation for the architect to deliver value in the process piece is starting to get much, much more interesting and much more complex. This is a slide from my friend Howard Ashcraft, who's the sort of leading attorney in the United States who works on integrated project delivery, and he talks about the design problem being, in an integrated project, being completely separate from the creation of the artifacts. So somebody has got to create these three design events: the design of the team so it functions properly, the design of the way they communicate with one another so they can achieve the aims that Shane is talking about, and the design of the actual workflow itself. So in my article in Scott's book, I was really only talking about the red bubble, but the meta design problem is actually all three of these bubbles, and the value proposition that I think architects are going to have to start thinking about is the extent to which we choose to apply the problem of design to all three of these characteristics. And the business models themselves are beginning to evolve in much more complex ways. This is a kind of lawyer. Howard's interesting. He's trained as an electrical engineer, so he's the only lawyer I know who makes these kinds of contract diagrams. And he can tell you with a great deal of precision where the innovation and creativity is supposed to happen and how that relates to the project outcomes and how we're going to share all the pain and the gain, and it's all worked out and it's very detailed. But it's a set of meta protocols that describe the interactions of the players around a different business proposition, which is to break this construct of, you give me a bunch of your mythologically interesting ideas on the left, and I'll see if you can dare the contractor to make them work on the right. The business models themselves are actually, at least in my view, starting to get refactored, and you begin to have to examine the meta design problem in a completely different way. This is an analysis from a paper that DPR Construction wrote about this project, where they were designing and orchestrating the design and construction of a large project from this big room, and this shows the number of data file interactions between all the players on the project. And they were using a template like this to manage the information flow and the intensity of the relationships based on the number of digital transactions. And I think there's a kind of mythology that somehow if we can get to 3D models that look like this, everything will be okay. This model looks great. There couldn't possibly be any mistakes in that model, right? Everything's perfectly coordinated, and all is right in God's universe if the world is modeled like this. And that's actually not it. Because in my view, this question of execution is about refactoring the relationships between these players. And I noticed when I was doing my project delivery lecture to my students last week that I inadvertently did this peace sign in the middle of this project delivery diagram. And so I don't want to get into this in too much detail in the interest of time, but I do think over the next decade, in this context, there are going to be some fairly significant transitions in the way the basic rules of engagement in the overlay that both David and Shane have described are going to occur. That there are going to be a lot of technological changes. There are going to be a lot of shifts in the use of technology. But the big change here, the kind of theme that flows through all of this is really twofold. One, someone has the job of conceptualizing and understanding the overall phenomenon that results in the building. There are meta design problems that are design problems, and architects, I think, have to decide the extent to which they are going to position themselves in the design of those processes in order to control the outcomes. The second piece that's increasingly apparent, I think, in the work that we saw previously and in the work that we're doing right now in our company is we're all working toward the problem of taking disparate piles of discontinuous, elaborated digital information and making them operate like single projects. Be able to look across a broad array of stuff and figure out how to glue it together so the project operates as a single entity. And architects have to decide if they're interested in just the formal aspects of that or they're interested in the performative aspects of that. And so if I return to this Smithson drawing that was in my article, this is an incredibly powerful piece of process information because it describes, this is Robert Smithson from 1599, describing how to build this round rose window in this curved wall. And all the instructions necessary to execute this incredibly complex thing are encapsulated in this one really beautiful drawing. And how many shop drawings would this take to do today, Shane? Maybe 200 shop drawings. It's really kind of scary. And because the nature of the delivery of information in a lot of ways has really changed, and this is where my technology breaks down. Because I do think that when you look at the broad trend of the problem, you see that the means of representation through building information modeling and the other techniques that we've talked about is starting to get consolidated. The means of delivery in terms of the relationships of the players is starting to get consolidated. And the timeline view of projects is also starting to get consolidated. And so what was once a kind of mythology of integration with all these pieces down below now becomes this problem of the representation of the entire proposition of executing a project. And the positioning question for a lot of architects is, where are we going to be in that process? Now, I think, Scott, you were probably introduced to Tom Basie when you contributed to my book. And Tom Basie wrote this really interesting article in the book that Peggy Deemer and I did about the design proposition and this concept that he calls flexible specialization. And what Tom Basie asserted, at least in our book, was that there are all these dots here represent various petals of the big flower that have to be assembled in some form in order to execute a building. And what Paula was asserting, at least back in 2007 when we did our book, was architects need to be like little froggies jumping around on these pads and be flexible enough that they can choose which parts of the process they need to actually be involved in. And I would like to make a slightly more dramatic assertion based on a couple of years of thinking about this, which is if we as a profession don't choose to position ourselves in this center spoke and define the design of a building as both procedural, or what Scott called the question of procedural efficiency, in addition to the mythology of the insight, the mythological and the procedural combined together, then we will, as a profession, be depositioned from the building industry. And the concerns that David expressed about procedural construction will come to pass in the building industry. Manufactured construction is happening right now, and you were mentioning about software replacing manufacturing. In our shop, we have this saying that in an American factory these days there are two organisms. There's a man and a dog. The dog is there to keep all the people away from the factory, and the man is there to feed the dog. And so, those protocols are going to start being used to build buildings. And I think as architects, we have to think about how we're going to do that. And have you guys seen this image, this 19th century postcard of the architect? It's a really fantastic thing where he's sitting in his computer-controlled box. He's reading his plan. I know that meant to say BIM, but it said plan. And he's controlling this robotically controlled job site. And in a way, it's charming, but it's also an interesting inspiration for the question of where we as a profession are going to position ourselves in this overall proposition. The value proposition is extremely clear. Clients are not happy with the way the building process is working. We got to choose how we deploy the thinking that Scott has pulled together in the book to reposition the profession itself, or we'll be, at least in my view, we'll be depositioned, and this romantic view here will pretty much be all that's left. So with that, Scott, I think we're finally done. Thank you.
So there's obviously a lot to talk about, but I do want to try to keep it focused and open it up to questions because hopefully you want to engage in this discussion. And I'm actually very happy with these three presentations, and I think it makes clear that the book was not about, consensus. It wasn't about, bringing people that are doing the exact same thing together to form like a sort of pat on the back kind of argument. It really was about trying to bring very, very different types of thinking together, ranging, I think, from the people represented on this panel from kind of experimental design thinking with radical uses of software to Phil's, insistence that as we talk about all these issues, that we simply cannot forget the fact that there's a value proposition that has to be made, that we can't just speculate without running the risk of just becoming further and further alienated. So there's two things that were repeated over and over in the presentations, and one was the myth of creativity, which David introduced and continued through all three talks.
Not the myth, the mythology. I think there's a difference.
Okay, the mythology, that's fine.
It's not a myth, but it is very mythological.
Right. But there's also, I think, a mythology of efficiency, which is also, I think, part of the discussions. And in some ways, I feel like that this, the way to tackle where we're at right now is by understanding both of those and trying to sort of reposition ourselves somewhere in between. That these things do exist. They are important. They're very powerful. The sort of mythology of creativity is very important to architects. I mean, in many ways, our kind of cultural currency is what allows some of the more radical buildings to be done. Now, whether you agree with that or think that's good or not, it's true. Maybe that's coming to an end, but it is still something that's very much part of the identity of the architect. So I want to just open it up and get each of your takes on how we begin to think about designing this new position of the architect within these kind of extreme conditions of the mythology of creativity and the mythology of efficiency. In other words, where do we go? We acknowledge this, but what's next?
Well, just as a simple observation, I think we should redefine creativity. And I think that's, in a way, I think each of us presented a couple of examples of how that could happen. But, especially Shane's examples of all of his projects, they use all of, they could have demonstrated some of the same points I was trying to make in that, they're using this technology that's has a tendency toward bottom line efficiency, but everything you showed has incredible creativity and shows the potential of them to do something new. And I think, Phil, you talked about some great examples of applying creativity to the design of all these processes, not only workflows, but other things like the organization of the team. And
Dan Friedman, who's just stepped down as the dean at University of Washington, talks about this idea of the false binary. And the false binary, in his view, is that somehow the ineffable and the efficient are in opposition to one another. And I think a lot of what both Shane and David were arguing is that the technology actually allows them to be conjoined in certain kinds of ways. That you can systematically explore a problem, but you can't solve it. I spent many years working for Cesar Pelli. And when we first started getting computers in the office, Cesar used to complain about the use of the computer for what he called the systematic generation of useless alternatives. You're using the computer, but you're not using your head. And what I think a lot of what you saw in the work here was the use of the tool to do what it does best, which is explore the problem space. But ultimately, somebody still has to synthesize the answer. So I'm not sure it's such a diametrically opposed problem. Or I'm being hopelessly romantic. You tell me.
But is there a point, let's say, is there a point in the use of tools of quantification or optimization tools or metric-driven design processes? Is there a point you think that can be identified where the sort of quantification of some idea, by the very nature of being quantified, loses its value? In other words, there's a point at which, by trying to shift and capture ideas within a computational process, that idea actually becomes less valuable as it becomes quantified. In other words, is that an important point to try to identify? Because certainly right now, I mean, all of you said this, the tendency right now is to move everything toward metrics, is to quantify everything and to know everything. And so I'm wondering how we begin to sort of figure out where that line is, where it becomes counterproductive. I'm sort of speaking on behalf of the people in the book who were more critical of this.
Yeah, see, I feel like for me, it's the quantifiable aspects of design, the things that you can run simulations on, you can get metrics or whatever, that actually free you up for everything in terms of qualitative. So it provides you a design space that you can work within. You have a confidence that you're going to at least perform to a degree that has been specified by your design, whether it's structural, energy, what have you. You have a space at which you can now work within, which for me, when I'm no longer given those sort of constraints, I've given this large space to work within, I feel I can be much more playful, be much more kind of directive with design, pushing and pulling things around as need be. When I'm also trying to simultaneously have to consider quantitative and qualitative, and I'm unsure about whether, in my calculations, I'm unsure about exactly what I'm getting out of the information, then I feel actually held back in design. So for me, in defining the design space based upon quantifiable metrics, I actually have a lot more creative freedom.
I mean, in a way, the conversation is slightly the quality of people worried about getting bitten by a shark at the beach. It happened to some guy in Australia, so they're really worried about it. And the idea that we back in our lab are going to write a beauty algorithm, that you'll get a beauty score, or somehow we'll hire David and he'll write some great software that will assess the beauty of your design. No chance. We're working on really basic stuff that clients care about. How much does this building cost? Will it finish construction on time? Can people get out of this building safely in a fire? These are basic things that are easy to do computationally and free designers up to do the hard part, which is make things beautiful. And there's a big gap between the quantification of the ineffable and building tools that make architects more free to explore more interesting ideas. You're not buying this argument, I can tell by the look on your face.
Well, I guess what I'm thinking is that you're then, but with that position, then are you running the risk of kind of putting all of the sort of the metric-driven information over here, and are you kind of prolonging the mythology of creativity? In other words, because I think one of the potentials of this is to merge this kind of thinking in a structured way. In other words, merge the ineffable, what you're talking about, with ways to measure it in a way that creates new types of teamwork, new types of collaboration. David, you talk about this. I mean, the democratization of design. I mean, that to me was a very strong concept, because in some ways what it did was take ideas that often in design processes remain very abstract and make them evident, so that they're debatable, they can be discussed, and what previously was the idea of a genius architect coming up with an idea that got executed becomes a much more interactive, productive discussion of competing ideas.
Explicit idea, right?
Make it explicit.
Right.
Yeah. There's Mario Carpa, who's one of my colleagues at Yale, who writes about the history of representation, who wrote the alphabet and the algorithm. He's gotten very interested in this idea of big data replacing everything. That if you just can record all knowledge about the world in a giant database, you actually don't have to know anything anymore, because you can just query the evidentiary data. And if you read Nate Silver's book, The Signal and the Noise, he completely destroys that argument, because he talks about the inability of humans to understand the difference between correlation and causation. And one of the great examples he uses in that book is predicting the weather. In the last, whatever it's been, 10 years since supercomputers have come along, we've actually gotten a lot better at predicting the weather because the models are much more sophisticated because they use these giant-ass computers to calculate all this stuff. But it turns out you can use a set of weather models and you can improve the accuracy of weather modeling by 25% by involving human meteorologists who look at the data and use human intuition to say, well, you know, the last time there was a hurricane in Kansas and a snowstorm in Texas, this happened. And it actually improves the outcomes by 25% in a completely non-computational way. And I think that's what we're talking about here. At least that's my view of it.
Yeah, that corresponds with what I was thinking, which is, you know, Scott, if you're pressing for an answer about what's the limit of the quantitative, I think it's that, or you know, where should we be afraid of it? It's if we automatically execute it without this kind of human interaction and judgment. Mm-hmm. And I think, you know, despite the fact that we both really love Kevin Slavin's idea that algorithms are kind of eating us, I think that there's a nuance to that. I mean, it doesn't mean that all algorithms are bad. You know, like some of the ridiculous outcomes that he describes in you know, such as a book on Amazon reaching a price of $31 million because an algorithm was processing data and kind of malfunctioning. Those things are not necessarily a threat if we have the kind of interaction with these systems that makes sense, you know.
I would say even more than just, you know, slavishly following the objective analysis. It's actually learning from that and enabling that as something that's part of your aesthetic approach. So elevating it up, so, you know, taking advantage of it. It's not just that it's going to give you a range to work within, and then you just do whatever the hell you want inside that. There's actually a dialogue, there's a communication that I think happens there that you can learn from that and actually elevate that up as part of your approach. And there's quite a few architects out there who will go through the process of, yes, they'll run some analysis, but then it's not just a matter of making some form within that. It's about elevating it to a kind of a greater degree of aesthetics.
Yeah, and I think the technology greatly increases the degree of transparency, but does not replace judgment. I mean, in the 5 parameters that you described in that project, David, the client still is not exactly sure what he or she feels about the trade-offs, and that's where an actual architect working with the client saying, the implications of this set of interactions are as follows. We can turn this dial all the way up and get this building, or turn this dial all the way up and get that building, but we're going to talk through what that means to you. Because otherwise, we'll set up a parametric skyscraper design piece of software somewhere and, you know, put 5 firms out of business next week, including several of our most important clients.
Yeah, and just along these lines, I mean, I think something that you guys both mentioned, which I think is really promising, is creating design tools that offer real-time information to designers. They're not making the decisions, they're just allowing you to see in real time what are the consequences of your design. I mean, you described literally the two monitors, one which is the form and one which is all the data about the form, and then the designer is the one who has to be in between.
Yeah,
so
the model's on the left and the dashboard's on the right.
Yeah, and I think, you guys are making great tools along those lines, and, you know, you've talked about it.
It's about being provided all the information that you need to make a proper decision coming out of it.
Yeah, you know, Mario talks about this idea that the essential problem since Alberti is CPU time, right? The problem, the original strategy that Alberti asserted about the abstraction of the model is a CPU problem. And what he's saying is buildings are these big complex things, and the only way we can express them is through high degrees of abstraction. And up to the end of the 20th century, those abstraction strategies were orthographic, two-dimensional projections in a super secret language that only architects and engineers could understand, called plans, sections, and elevations. Now that we essentially have infinite CPU power, and frankly a generation of clients that grew up buying Xboxes, the integration of of representation is going to be a completely different thing, because CPU power is unconstrained. I can run 10,000 energy analyses because it doesn't cost me anything anymore. I can keep 43 high-res rendering engines active in my model at the same time because there's no CPU overhead to that.
I think one of the things I just came back from 2 weeks in Australia, and one of the things that we kept running into with a lot of the people's in design reviews was this discussion about representation, about ways at which we enable new kinds of design review to understand the buildings as we design them. And quite a few of the architects are still of the position of always looking at things in plan, section, elevation. Maybe we're lucky if there's a 3D view shown up on the screen as well, whereas a whole other set of them have gotten to the point where representation is very fluid. They're always pulling up different bits of information. They're opening the model in Revit, querying information, live sections, spinning around, marking things up on a very live basis. So for them, that type of representation is a much richer form, and it provides them with a larger set of information which they can continue to make design decisions, rather than this reduced set that exists in two-dimensional forms.
Okay. I think we should open it up to questions from the audience. I mean, I have a lot of other questions, but let's go ahead and, anybody has any?
Paul always asks the first question.
In previous generations, there was always an underlying polemic to the creation of the architecture. If you look at Le Corbusier, I mean, he shows the modular, which is essentially parametric, it's quantified, it's based on mathematics, but there was an underlying polemic. And in the case of Smithson, in the case of Alberti and Brunelleschi, we always have this type of polemic. I didn't hear anyone really talk about the polemic of our age. And I noticed David talks about the democratization, which is essentially like booking a flight on kayak or orbits. You want to go from point A to point B, any airline, anytime, you have 3,000 choices. But if you start to filter this down, the choices become less, and one becomes one's client in that sense, using the technology. But I'm really curious if any of you see or can deduce what the polemic of our age is, because without that, we basically have a series of mathematical solutions without a progenitor for design.
I thought polemic died in about 1983. Just at that exact moment I got out of grad school. I mean, I don't have an answer to that question. I'm a weapons manufacturer. I expect you to go out and wage war, Paul.
Well, to me, I mean, to me, the tools are totally compatible in the approaches, and and even the idea of democratization of design is compatible with ideas driving the projects. So I still, I think there still has to be an idea. There still has to be judgment. There still has to be a way to balance things and drive the decisions. And I think the powerful model of using computational tools to debate values is different than kayak. I mean, even though in a certain sense kayak is applying filters, and in a certain sense you could use filters to eliminate design options. But I think, and it's because what I mean by democratization of design is that there would have to be a debate. We would have to come to a common understanding. We would have to each expose our values and interrogate our own ideas in order to negotiate a decision. And I think that's that's where the ideas would come in and drive each other, influence each other, battle one another.
I was going to say, even if I decide to buy a car, I could take the most optimized design, but there is still some emotion or some affiliation in that purchase of the car. It might be, it's great in terms of fuel efficiency, So I have a green polemic that I want to pursue, or I don't care about that at all, and I simply love the design of the Ferrari, and I want that regardless of its optimization and its fuel efficiency. It's purely hedonistic. So how do you distinguish that? How do you impart that in terms of the design process?
If I can intervene, I think that's a bad example, respectfully, because I think that green cars, most people don't understand the data behind them and what their efficiency levels are, and just because you have a green dashboard with a smiley face, it doesn't mean, you're going to have an effect on climate change. So I think that's a false. You're making a false choice in choosing between a green car and a Ferrari.
Well, with all due respect, there is a label on that car. We don't have those labels on our buildings. That label tells me
that's
that
it, but
does
that's-
give me
yeah.
some information. And then I make my choices.
But I think that we all need to be much better educated in the ways in which data is presented to us, and I think that's what we're talking about. Not a split-second choice between making one aesthetic decision over another, but understanding the huge amounts of data that we have access to that we didn't have access to before. We're compelled to use that data now, especially as architects. To be responsible architects, we have to account for all this new data. But we're not learning, we're not necessarily being taught about it, or how to distinguish between the design of data, data that comes to us already interpreted, that has a specific point of view. We're just taking it as objective fact, whereas we need to evaluate the data that's given to us in relation to driving our designs. So it's that's why you have to go back to the Renaissance, or Mark Rakitansky can fill you in over there. But we've always had tools which have conditioned our way of seeing, and the way, and that the world has always been interpreted as a set of data, from longitude and latitude to perspective, Cartesian systems, etc. So I'm not saying that that's exactly the same either. I think they have a whole new problem today, but I think that the panelists really opened up what those problems are and what our responsibility is in making choices.
Mabel?
Yeah, I guess the question, one of the questions that I actually have to all four of you, and I think Scott, you know where this is coming from, is the question of, maybe it's back to David's question of the bread and the wine, right? Because fundamentally there has to be some kind of equilibrium about how the people who are working within this flow chart, the system, the laboring body of the architect versus also on the other end, downstream, the laboring body of the construction worker, are able to sustain themselves within the system. So it's both the distribution of, obviously, the economics and the money, there's the distribution of knowledge, and the ability for this very complex system to sustain itself long term. And so how does one find equilibrium within that system? Because part of what I hear is happening is both the physical labor of the architect and the intellectual capital of the architect is potentially marginalized within this system, and something else is coming in to fill, I think, what's great about Phil's diagram, which is that central point in the middle of that triangulation.
Well, I guess as the corporate guy, I should maybe answer this question first. The marketplace will find its own equilibrium, as we know. The assertion that I make is that architects have a window of opportunity to position themselves in the making of that new equilibrium. That 10 years from now, many of the protocols that Shane designs himself will be very well understood, and there will be I don't want to say a battle, but there will be a struggle over the control of those protocols and how architects engage in them and how other players in the process engage in them. And so my argument is we have to assert ourselves into the system to create an a state of equilibrium where design has a significant presence, or the system will push it completely out. Because in the age of the only measurable, if the only polemic is measurement, then design is going to disappear. I was giving a lecture 6 or 7 years ago at Ohio State about the emerging principles of integrated project delivery. We were I was talking about this idea that, you know, you could create a business model where measurable outcomes like cost and schedule and sustainability were the business proposition instead of commoditized fees. And Rob Livesey, who was one of my former professors, who was the dean at Ohio State, said, well, if you set up a system that looks like that, it will self-optimize for those variables, and design quality will go completely out the window. And so I was actually in the process of setting up an IPD project where I was the client, and I thought, holy shit, he's right. I'm going to get a perfectly on-time, LEED Platinum, ugly-ass building if I do this IPD project. So we began exploring this question of how you could optimize for design quality, but the measurement system that we used was completely non-algorithmic. We hired someone we trusted, and that person had unilateral decision-making power over the project to say, yes, this client got what they wanted, or no, they did not. And the team was rewarded accordingly. We had to build that kind of judgment into the system, lest I, optimize myself into an ugly headquarters building. Did I answer your question?
I'm also thinking about what I mentioned in the introduction about, and this might be a generational thing, but what Tom Main said related to that issue, which is that the architect's most effective strategy to drive these processes and not be driven by them is to design, he literally used the term, aggressively aesthetic buildings. In other words, that form, which is the enemy on this panel probably, in fact has been, over the last 10 to 15 years, what has driven much of the progress that's occurred in fabrication, in construction. You might disagree with that, but I think so if that's not what we bring to the table to equalize, to kind of resist, or to kind of engage, and I don't think that is sustainable, then the question is, what do we bring?
Is formal aggression the only form of architectural aggression?
See, I would slightly disagree. I wouldn't say that necessarily form on its own is the thing that has caused fabrication, development, construction.
Not on its own, but
there's a level of consideration for fabrication, materiality, all those types of things that has actually pushed the industry. So I think I would agree with Tom Main's comment, which is you have to keep pushing the industry, otherwise you're going to reach a level of complacency where you do just have everybody is able to do the same thing in the same piece of software. So there's always has to be a challenge to keep pushing people forward. And I think that's, for me, is one of those roles of the architect in this. So there's an aspect of that, of yes, they needed to design the process of communication and manage the communications through and set themselves right at the center, because I would agree, as more and more people come in as BIM managers on projects, or contractors come in and serve that particular role, the architect just becomes a stylist, continually pushed around the outside edge. So I think our role as instigators, challengers, catalysts, all those things at the same time is what's going to keep a lot of the industry moving forward. To go to kind of one of your comments before, I think for me, one of the things that can allow us to reach this point of change at which we can progress. So, for example, you showed that image up on the board, the text on the board, which was 2011, 2021. I was honestly hoping 21 was a little bit earlier in the future, and I started to think to myself, what are the things that allow you to get to those types of points, to get to that level? It's not technology. I mean, we can have a lot of those things in place in the next year or two if we just put a little bit of muscle behind it. That's not a problem for us. It's about how we deal with each other and work with each other socially, and how we communicate with each other, and the level of trust. It's very easy to start foreseeing an opportunity that if you get a really good team together, people who've worked well together, they've communicated well together, you have someone who's really pushing the survey as a catalyst in this. Again, I always go back to the references of music again, same type of team working together in a tight-knit group. You will create something amazing out of it. You don't necessarily have to have a single signature design, aesthetic, or approach from one person to lead that effort, but it's about putting together a good process and a good group of people.
I think it's too easy to say it's not about the technology, because I do think that it's how we leverage the technology as architects that's going to be what puts us in a position to, be effective as, as somebody who designs industry or designs assembly or does these meta designs that we typically don't do. So I
guess I would say it's just not a, it's not a limitation.
it's not going to be the technology,
Yeah.
but the change is going to have to come through technology-enabled processes.
Yeah.
But interestingly, this fascination with form generation and simulation, the manufacturing industry went through this 15 or 20 years ago. They're done. They've already figured this stuff out. Their fascination these days is around workflow process, what's called PLM, Product Lifecycle Management. How do you hook all the players together and optimize the processes? We're just, as usual, 15 years behind those guys. And I am advocating that we are more aggressive about applying technology to the process components of the problem before other forces in the supply chain design those neural pathways for us and really, really narrow our options. So you're right, it is about, it's not technological determinism. Technology is a catalyst to solving a series of problems, but we have to decide that we care about the problems. It's not that form is the enemy, it's just what we've been fascinated with for the last 15 years.
But isn't that what culture gas does? To say, hey, architects design our buildings. Don't design our processes, give us our buildings.
And I'm arguing the failure to do the latter will prevent us from doing the former.
I agree. I mean, it's multiple cases. You look around, you see, court cases left and right where it's been a failure in communication, a failure in process that was a barrier towards either a building performing efficiently, being done on time, being fabricated the correct way. It's again and again, all the sort of, BIM alarmist articles out there are always about breakdowns of communication. So I think if we can figure out the process side of it, figure out how all these players are supposed to work together, we have many fewer barriers to actually get that type of architecture that the clients are asking for.
So is that being taught at Columbia?
Yes.
Good answer.
How much do you see the computational tools influencing the question of design aesthetics? For example, with Morphosis is purely, I would say, let's be charitable, willful driven form, as opposed to form that really is influenced by absolute environmental data, not relative, spin the building 4 times around and average it over the worst energy hog, but actually look at ways of saving energy. Because a lot of these buildings strike me as form for form's sake, and the kind of thing that you'll look back in the same way you'll look back at mounted heads on the wall from the turn of the 20th century. And that the tools seem like there's the potential for not allowing us to hide from our choices about energy consumption. And I'm wondering if we see that coming up through the design process.
Well, for one thing, we're going to start, more and more kind of regional entities or government entities are going to require us to give information about performance for the building. So even if there's something willful, does not necessarily mean it's not going to perform up to expectations. I think it's those architects who are able to take both these together, to synthesize them, to have an aspect of the willful, have an aspect of the form generation, something that really achieves a high aesthetic character, while also providing something that performs to a high degree, is where you get absolutely amazing, great architecture. So I think you're always going to find a bit of both. I think you're going to find people who don't care so much about energy efficiency, solar analysis, any of those types of items, but at some point they will be held accountable for the performance of the buildings. On the other side of it, I think it's very easy for people to, run all sorts of systems through computational tools to come up with the most efficient design and have one of the most horrendously ugly buildings you could possibly imagine. So I think it's a dialogue between the two of them. This is why we were talking about before, the balance between the quantitative and the qualitative. I think if you can provide yourself a design space to work within that is on the quantitative side, you can then elevate that qualitative to a higher degree.
But I will say that one of the things that worries me, now that I've been in the software business for whatever it is, 12 years, is the degree to which less engaged architects rely on software capabilities to design their buildings. I mean, I can drive through an American city and within the limits tell you That's an AutoCAD 14 building, that's an AutoCAD 2000 building, that's a Revit version 1 building, that's a Revit version 5 building. That's not good. That's not what we're trying to do. But it is, in fact, tools are deterministic in that way, especially for the lazy.
Yeah, you walk around universities all the time. You can tell when someone's only been through 1 year of grasshopper training because there's 3 or 4 cliches that show up every single time. It's and actually, to be honest, that shows up in built form all the place. You see it everywhere. So I'm the same way. I can walk around a studio, I can walk around an office, I can walk around different places and start to pick out, oh, they did that particular function in Grasshopper, oh, there's SketchUp right there. It's again and again. So I think we have to transcend that. We have to internalize our design process, bring it out further beyond what our tools are actually going to give us.
I think we have to wrap up. But anyway, I just want to thank the panelists for participating. James Catronis is here, one of the authors. I want to thank you and everybody else that was involved with the book. And just end with a plea to the students. I mean, I think to a large extent this is a generational issue, that a real fundamental change, the type of change that we're talking about, that Phil's talking about with meta design, it's going to be hard to do without a real shock. And I think it's going to take a generation that comes out with a fundamentally different way of thinking and defining design that goes beyond just architecture and goes to some of these sort of processes and sort of engages in them as interesting design problems, not obligatory design processes. And I think that hopefully that's starting to happen. So thank you, everybody.